Alright, hello class, welcome back to 2.7. We're going to look at part 2, so if you haven't viewed part 1 yet, please go ahead and find part 1 and watch that first. So we're looking at another absolute value inequality. This time we're dealing with the symbol less than, and less than or equal to. So we want to know when the distance of our value is going to be less than 4. So when we're talking about less than 4, we're talking about the distance less than 4 is between negative 4 and positive 4. The absolute value of negative 3 is less than 4. The absolute value of positive 3 is less than 4. Okay, so we're working with values in between. There's two different ways of writing this. This is sort of the shorthand of writing it. Notice that we have the compound inequality where we have negative 4 is less than x, which is less than 4. Also, which may look a little better to you, is using the word and breaking it apart just like we did with the last one. We're going to have x is less than 4, original, and we're going to have x is greater than negative 4. Okay, so less than 4, greater than negative 4. Right, so don't get confused with the notation. Okay, so here's our rule, our math rule. And again, we're talking about the absolute value is less than k. Remember, this can be less than or equal to. Notice they have it written in the shorthand. So you could also have ax plus b is less than k, and ax plus b is greater than negative k. Okay, so if you wanted to use this notation, we could go ahead and write it that way. So let's go ahead and look at our first example here. We want to identify, do we need to move anything over, just like the other ones? Nope. Look at our symbol. It's a less than or equal to. So I'm going to use this right one because I think you're probably more comfortable with that. So we have negative 6x minus 6 is less than or equal to 1. And, remember to use the word and because we're using a less than or equal to symbol. Negative 6x minus 6 is greater than or equal to negative 1. So notice that I've flipped the inequality and it's greater or equal to negative 1. So we go ahead and solve. Add 6. And we get negative 6x is less than or equal to 7. Divide by negative 6. And we have x, we divided by negative, so go ahead and flip the inequality symbol, and we have negative 7, 6. Go ahead and solve the other one. Add the 6 again. We have negative 6x is greater than or equal to 5. Divide by negative 6. And we have x is less than or equal to negative 5, 6. Remember to include your and statement, so we want to go ahead and throw our and there. So now we're looking for where these overlap. So let's go ahead and get our number line. Okay, so we're at, here's our 0. Here's my negative 1. Now if I turn these into decimals, I'll see that negative 5, 6 is almost the negative 1. And negative 7, 6 is just past. So if you need to turn those into decimals to see where they're at, you can do that. And let's graph our first one here. So we're greater than or equal to negative 7, 6. So I have a bracket at negative 7, 6, and I'm greater than. Okay. We go ahead and graph less than or equal to negative 5, 6. So we're at negative 5, 6 with a bracket again, less than or equal to. And what we're working with this time is an and statement. So all we're interested in is the part where they overlap, which is going to be this region in between. So if I write the solution, I'm going to use interval notation. We have negative 7, 6, comma, negative 5, 6. All we're interested in those numbers between negative 7, 6 and negative 5, 6. So that's working with a less than or equal to. Big difference. We're dealing with and instead of or, and we want that region in between that we're working with. Let's try another example like this. All right, go ahead and pause and give this one a try, and then when you're done, come back and I'll show you how to do it. Welcome back. All right, hopefully you were able to figure this one out, but let's go through the steps. First thing we want to identify is this minus 6 is on the same side of the inequality, so we need to move it over first before we do anything. And that gives us the absolute value of x plus 5 is less than or equal to 5. So I've moved it over. Now I can go ahead and break this apart. So what we're looking for here is we have a less than or equal to symbol. So remember when we're dealing with a less than or equal to, we're going to break it up with an and statement. Okay? So I have x plus 5 is less than or equal to 5, and x plus 5 is greater than or equal to negative 5. I'm not using the shortcut of combining it together. If you'd like that, you are welcome to do that. And that would look like negative 5 less than or equal to x plus 5 less than or equal to 5. So if you want to use that notation, this would be the other notation. So we go ahead and solve these. Minus 5, minus 5. And that gives me x is less than or equal to 0. And minus 5, minus 5. And we have x is greater than or equal to negative 10. Okay, so we have two things going on here. We have less than or equal to 0 and greater than or equal to negative 10. So let's go ahead and graph this, and we'll also write it in interval notation. Remember, you can always pause and go back and see what's going on. So let's look at our first one. Less than or equal to 0 is a bracket at 0, and less than, so to the left. Greater than or equal to negative 10, so we have negative 5, we have negative 10. Again, greater than or equal to is a bracket, and we're going to go right. So the solution, if we graph it, is going to only be the areas where we have overlapping, since it's an and statement. So it would be from the negative 10 to 0. So if we write that in interval notation, we basically just drop down and remove the number line, put a comma between, and we have our solution. So values between negative 10 and 0. The next type we're going to look at is where we have an absolute value equal to an absolute value. So when we're working with absolute values, if you read up here, when we have them equal, it says if two expressions have the same absolute value, they must either be equal or be negatives of each other. Okay, so the first statement, we have an absolute value equal to an absolute value. So we break it apart by just basically removing the absolute values. The other solution, notice where we're using the word or again, we have the absolute value of the first one is equal to the opposite of the other one. Okay, so we take out the absolute value and set it equal to the opposite of the other one. So let's look at an example of this. Again, we're going to break into two solutions here. So I have an absolute value equal to an absolute value, so that's telling me to use this definition, and it's telling me to break it apart into two equations with the word or. The first one is if we just eliminate the absolute values, and we have first one equal to second one. The second one is we have the first one equal to negative the opposite of the second one. Notice how I'm using parentheses. So let's solve our first one here. We're going to subtract 9x to bring that over. And that's going to give me negative 3x is equal to 1. And divide by negative 3. So we have x is equal to negative 1/3. Or, when we solve the other one, we have a 6x equals, we need to distribute the negative 1 in first. Gives me negative 9x minus 1. Okay, so remember to distribute the negative sign in. Now we can go ahead and solve this like we would with the other ones. I'm going to add 9x over since it's negative. That gives me 15x equals negative 1. Divide by 15. And we have x is equal to negative 1/15. So since we're dealing with the or statement, both of these are considered answers. And we write them as a solution in a set. So we have negative 1/3, comma, negative 1/15 as our solution for number 83. So similar process, you just need to remember to include this opposite sign over here. Okay, so let's look at a few special cases. Now take a moment and look at this problem and figure out what is wrong with this problem. Why is it a special case? Well, we have an absolute value and it's equal to a number, but notice the number is negative. So the absolute value of something is going to equal a negative number. Is that ever going to happen? Are we ever going to have the absolute value of something equal to a negative number? And the answer to that is no. In order to solve these in order to solve these absolute equations, we need it equal to a positive number or 0. So for this one, we have no solution. Okay, the absolute value is never going to be equal to a negative. Let's look at another special case. We're dealing with an inequality. We have a plus 3, so let's go ahead and subtract that over first. And we have the absolute value of 10x plus 7 is less than -2. Okay, that was a subtracting 3 over. So again, we look at this concept and we think about, is the absolute value ever going to be less than a negative number? Again, in order for this to happen, the absolute value itself would have to end up being negative. Okay. We know that that's not possible. Absolute value in a number is not going to be negative, so it can't be less than -2. So again, this is a no solution case. Let's look at another special one. So we're going to solve the equation, and the only thing you want to notice is, so with this problem what you want to notice is we have the absolute value equal to 0. So before, when we were dealing with an absolute value equation, we'd break it up into the value and inside the absolute value was equal to the positive, and the value on the inside was equal to the negative. Well, since 0, we don't assign a positive or negative sign to it, we only have one solution for this. So we're going to go ahead and just solve the equation. 4x plus 1 equals 0. We want to know when the absolute value is equal to 0. Subtract the 1, and we have 4x is equal to -1. Divide by 4, and we have x is equal to -1/4. There's only one solution for this problem, and it's when we have x is equal to -1/4. So our solution set is just -1/4. Let's add another one. Again, we have plus 3 here, so let's go ahead and subtract that over before we evaluate anything. And we have the absolute value of x minus 2 is greater than or equal to -1. Again, take a look at what this is saying. It's saying the absolute value. When is the absolute value of something going to be greater than or equal to -1? Well, we know that when we find the absolute value of something, it's going to be a positive value. So this is going to always happen. We're always going to find a value greater than or equal to -1. So our solution for this one is -infinity to infinity. If you want to go ahead and break this one apart and solve it, you would find that solution. But just looking at the problem, we should be able to identify that it's going to be our all real numbers, or -infinity to +infinity. Alright, let's look at one word problem, and then we'll be done with section 2.7. So go ahead and pause me and read through this, try to come up with an idea. Okay, so what we're dealing with here is the recommended daily intake for calcium, and females ages 19 to 50 is 1,000 milligrams. Actual needs vary from person to person. Write the statement as an absolute value inequality. Okay, so we know what we're looking for one of our answers, with x representing the RDI, to express the RDI plus or minus 100. Okay, so what we're going to do is we have the total amount that someone intakes. Okay, that's something that we don't know. We want it to be, after we subtract off the recommended dose, we want it to be plus or minus 100 milligrams. So the first one I know is if I take these two and I subtract them, I want it to be less than 100. That would fall under the plus 100. And the other one that I want is when I subtract these, I want it to be greater than or equal to -100. Okay, that's the minus 100. So we want our value to be plus or minus 100, somewhere in that region. So if we go ahead and look at putting this into an inequality, well, what ends up happening is you have the less than or equal to 100, we have the greater than or equal to negative 100. So look back at your notes and look at the greater than and look at the less than symbols and see which one does this fall into. So hopefully you're noticing when we're looking at the less than, this falls into the absolute value where we have x minus 1000 is less than or equal to 100. If we were to split this apart, we would get the original, and you would flip change the sign to get to your negative. So we're sort of working backwards here. We've created the two different ones, and we're trying to get it to the single one. Okay? So this would be our absolute value inequality. Now to solve these, all I need to do is add 1000 to this one, and I get x is less than or equal to 1100. Over here, I add 1000, and I get x is greater than or equal to 900. So what we're talking about is we're talking about values that are less than 1100 or greater than or equal to 900. So again, if we graph this, we're greater than or equal to 900, but less than or equal to 1100. So interval notation, we're between 900 and 1100. Okay. Well, hopefully that helps you with 2.7. If you have any questions, feel free to let me know.